The PLC logic was completed in the last video, and in this video we will start making HMI in WinCC. Create a new project, single user project, name it as HMI for motor control. Before starting to develop the graphics, we will establish a communication between this WinCC software and the PLC. And after establishing the connection between the PLC and HMI, we will add all these input-output bits into the database of the tag management section of WinCC. As you can see in the logic, we have bits like I0.0, M1.0, M2.1, Q4.0. All these bits has to be included into the tag management section of the WinCC database, because only then we will be able to access these tags onto the HMI of the WinCC. So for that, I will go to the tag management section. Add a new driver, semantic S7 protocol suite. Since the communication link between the WinCC and PLC, in this case is MPI, it can be any driver. It can be an Ethernet driver or it can be a Profibus. In my case, it is MPI cable. Click on this new connection, go to the connection parameters. If you look at the hardware configuration of my PLC project, the PLC rake 0 and slot number 2, it has the CPU of the PLC. So I will add 2 in the tag management section, rake 0, slot number 2. To check whether the connection between the PLC and WinCC has been established, for instance, for that I will go to the runtime. Well, this green tick indicates the connection has been successfully established. Let's deactivate the project and start to add all the IOs in this section as tags. I'll simply name them ready. Ready is the signal, that is binary tag. Well, new connection 1, this is the name of the connection. It will be fetched by default. You have to add the address since input 0.0. Copy this to avoid wasting time. Run feedback, and its address is I0.1. This is the overload, and its address is I0.2. Local start and local stop. I think there is 0.3 and 0.4 respectively, but let's check it. Go to the symbol table, I0.3 and I0.4. Go to the tag management section again. 0.5. Now it's time to add memory addresses. HMI start, M1.1. You can add directly as well from the keyboard. HMI stop, binary tick, and M1.2. The status of the motor operating mode. I think it's M1.0. M1.0. Q4.0 is the command. I will add this as well to the database. And finally, it's the motor command. Q4.0. So all the necessary digital tags have been successfully updated into the database of the WinCC. Now I will be able to access these bits onto the graphics designer HMI. I'll cancel it. In the graphics designer section, there is no HMI. First, I will add a new one, or you can save it from here. That's it. And I will define it as a start screen or start picture. The first graphics designer page has been created. Now I will add buttons and text onto this page, and will link the digital tags to these buttons and text, right? First of all, add some text. Induction motor operation. Click on the properties. Effects. This one. Now I will import buttons. Motor start. Well, as a demonstration, I will add some script to this button because I have to set the M1.1 memory bit high when this is clicked, because the remote operation would be controlled from the operating station's HMI. Go to the properties of this button and I will click on events, mouse. Well, when it is pressed left, when we press the left button on the mouse, it has to set the memory bit M1.1. M1.1. This has to be set high. When the start button, this one is pressed, and when it is released, M1.1 would be set low, right? Just like the push button that is installed in the local control panel. When we press that push button, high signal comes to the digital input channel of the PLC, and when it is released, well, the high signal is gone. So the HMI start button has to act like this as well. So for pressing, I will attach a C script, very simple. Just I will set the tag high. Internal functions, tag, set tag bit, double click on it. Well, the tag name is HMI start and the value has to be 1. Very simple. Compile, no errors and warnings, save it. Let me save this. Well, set tag bit, and when it is when the left button is released, the aforementioned bit, that is the HMI start, has to be set low, just like the local start push button. So the script for this button is complete. Let me describe it, what we actually did. Whenever on the runtime HMI this start button is pressed, the left button of the mouse is pressed, the M1.1 would be set high, and whenever that button is released, M1.1 would be set low. Pretty simple. Copy paste. I'll just change the name. Events, mouse. In this case, I have to set high the HMI stop button, because if you look at the logic, M1.2 is a stop motor from HMI. So normally it is low, and whenever M1.2 is pressed, whenever the left button of the mouse is pressed, M1.2 would be set high, and in that case this network would be opened and M2.1 would be set low, and ultimately the motor command would be withdrawn, that is, the motor would be stopped. So I have to change the digital tag only. anyways, do it again. Set tag bit, tag selection, HMI stop, M1.2, and the value has to be 1 in case we want to stop the motor because it is NC contact. If M1.2 by pressing that button is set high, this network would be opened and motor would be stopped. Copy it. Upon releasing the left button, the stop digital tag, HMI stop digital tag would be set low because we do not want to permanently set it. It is just a momentarily high-low signal button, right? Save the project. Just to check whether we have made the logic and scripts so far right. So let me go to the runtime of the HMI, activate the project. Let me monitor the project. Sorry, we didn't download it after making modifications. Well, M1.0 is low. It's not in the remote mode, so I have to add the button of the remote in local mode as well into the graphics designer HMI. Copy it, paste it. Remote. I have to delete these two scripts because the script in this case is somehow different, so I will have to attach it to mouse click. When the motor operating mode is local, upon pressing this button, the mode would be switched to remote, and if it is local, and if it is remote, it would be switched to local. So for that, I have to add the script rather intelligently. But before doing that, I have to get the tag status, the digital tag, get tag bit. And that is local remote M1.0. I will define a Boolean variable, and that Boolean variable will get the local remote status. Let me compile the project. No errors, good. If flag equals 1, it means the mode of the motor operation is remote, and in that case I have to set the bit to low to switch it to remote mode. Zero. And in case if the flag is 0, that means the operating mode of the motor is local. So in that case, I have to set the M1.0 variable to 1 to switch the mode to the remote. Compile the project, no errors, okay. Let me go to the runtime. Now I'll monitor the logic and we'll check. Click the remote button and see whether the M1.0 has been set. Yes, it has been set high. So I0.2 overload and readiness has to come. So I will set these from simulator. I'm not using the physical PLC, I'm just using the simulator, but the process is entirely same. There is no difference. Provide ready signals and overload signals. Now the logic is waiting just for the HMI start button to come, because it is now in the remote mode. The local mode bits would have no impact on the logic because the local mode is not activated. Now if I press start, M1.1, M2.1 was set high, the motor started operation as well, right? But the motor was stopped after 5 seconds because the feedback signal I0.1 didn't come. So if I set the I0.1 from the simulator, click it, and now the feedback has come and the motor is in operation, right? The motor started operation from HMI. This button triggered the operation of the motor. And if I click this one, stop, well, the motor is stopped, right? So the logic and HMI both are working fine, right? Now let us make some additional modifications to my graphics HMI. I will store the status on the HMI. For example, ready signal, run fault, overload, local start and local stop command. And I will also add the motor graphics onto the HMI. So for that, symbol library, plant elements, motors. This is not the one that I need. You can add anyone, but this one seems good. So I will import it from the library and will save to my graphics designer. Now, if the motor command is high, that is the Q4.0. If this Q4.0 is high, I will set the color to green, and if it is low, I will set the color of this motor to red. You can use run signal as well, the I0.1 run signal. But for clarity and for understanding, since I'm using simulator, I'm attaching Q4.0, but you should use I0.1 if you are using a physical PLC. Go to the properties of the motor. Here the color section. Dynamic dialog, boolean, get the status of the tag command. If it is yes, set the color to green, and if it is not high, it is low, set since Q4.0 is low, this is red. If I click the button, it is set green, and immediately it would be set red, because since no feedback is, oh yes, feedback is coming from the field. Actually, I have set it high from the simulator. So it is green and its operation and its command is high. Stop, it will be set red. Now few of the remaining digital tags like ready, run, fault, start and stop would be updated on the HMI as well. Add some text like ready, electrically ready. Make some modifications to look good. The color of this box has to be green if the ready signal, that is I 0.0, is high. For that, click on the properties of this rectangular box, go to the colors, background color, dynamic dialog, boolean, get the variable as ready. Okay, if it is high, set it green like this one, and if it is not, you can set it red. Now copy paste. Run. Overload. Local stop. Start. Remote mode of the motor, and you can also add last as the motor command. Now I just need to update in this case. I will add the run. Check whether it is okay. No error occurred. First of all, remove this already existing signal. Overload. Local start. Local stop. Remote. Well, if M1.0 is high, that would mean remote mode, and if it is low, that would mean local mode. Finally, the command. To To a large extent, the HMI is complete. One more thing, I will change the text of this button based on the condition of the M1.0. For that, I will click on this, right click, and add some script. And for script, I will first of all define bool, flag, or temp variable, and this temp variable would get the status of M1.0. Assign temp the status of M1.0. That is the local remote variable. And if temp equals 1, this logic would return the text that is remote mode. Else return local. The button would display local. Compile, no errors and warnings, very simple. So the HMI is almost complete. Once again, I will deactivate the project and will reactivate it. So ready, run. I have set the run bit from the simulator, overload, local start, local stop, remote, local. Very simple and very interesting, very cool. If I click the button now, there is no impact on the motor operation because the motor is in the local mode. If I change it to remote mode, now the motor is in the remote. I click the button, it will start operating, and on stop button it would stop operation. So hope you understand it. This was the process of making logic and HMI for the local remote operation of the motor. If you have any question, you can ask me in the comment section, and in the coming video I will make logic for the automatic operation of the induction motor. This was the local mode motor operation, remote mode, and one step further we will make logic for the automatic operation of the induction motor. Hope you guys liked it, and if you have any confusion or question, definitely you guys can ask me in the comment section. Thank you.